All right, guys, here we are. It's Friday. We made it through the first week. Hey, even if it's short, I'll take it. 1 week down, a bunch to go. But anyway, so here we are. We're going to be finishing up our categorical data. So without any other hesitation, let's start. So we're going to be looking at displaying and describing categorical data. And we're going to look especially at contingency tables. And here is one. It allows us to look at two categorical variables together. So what we're looking at is the interaction between two variables. We've got class and we've got survival. So this is on the Titanic. And we're going to see, what kind of meaning we can get out of the, the survival rate of these different classes of people. And maybe there isn't any kind of a relationship between, the expense of your ticket and whether you lived or not, or maybe there is. We're going to find out. So what we've got in a contingency table is showing how individuals are distributed along each variable contingent on the value of the other variable. So we're actually looking at two categorical measurements at the same time. So for example, if we look right here, this 178, these are third class people who survived the wreck of the Titanic, whereas this 673 are the number of the crew who died on the same ship. So yeah, lots going on here. So let's move forward. All right, so we have a couple of margins here. We're calling them marginal distributions, and there's one at the right here, and there's one down below. And those are like margins that we would find on a piece of paper. They're just sectioned off little areas that kind of give us some subtotals. To look at these two numbers here circled in green, those relate to whatever is across from them. That is whether or not somebody survived, dead or alive, okay? So out of 2,201 passengers, 711 lived, 1,490 did not, all right? If we look at this is not circled, these four numbers, but they represent another marginal distribution, and that would refer to what's up, all right? So up from that is the class, and that's the type of passenger that was there. First class all the way down to crew, okay? So if we are talking about survival, we're talking about left to right. If we're talking about the class of the passenger, we're talking about top to bottom. And these numbers within the body of the table are going to be joint values, because this one here, 203, these are people who lived, but they're also, or the word and, first class passengers. So it's the intersection of those two categorical variables. So again, we've got a table, we've got a grand total here, we have one marginal distribution here for survival type, we have a second one here down at the bottom, and that's going to be for subtotals for class on the ship, and then we have all these 8 joint situations. All right, so I probably told you more than I needed to, because here's another slide with some of that information. So these 8 things in the white area are cells, and they're the combination of two values. They are joint values where interactions occur. And for example, this number here, these are crew members, and these are crew members who died. So there's your AND connector. That's what a joint value is. It's two things connected with AND. Okay, there's more that we can look at, and this is going to be important. We're going to see this pretty much throughout the first semester. At least it'll show up toward the end. This is a conditional distribution section, and it shows the distribution of one variable for just the individuals who satisfy some condition on another variable. So the following is the conditional distribution of ticket class condition given on having survived. All right. So this is the condition. It's alive. You notice that the table was shrunk and the dead people were taken out, right? So we're only looking at those who lived because we have a condition, or given that the people survived. And then the question is, what are the percentages? All right, so here's your total. If we take 203 out of 711, you get 28.6. And if you take 178 out of 711, you get 25.0%, and so on. They got to add up to 100%. So what percent of survivors are in first class? That's 203 out of 711, and we said before that that's 28.6. So the words if, the words given that, those two, there are other ones too, I just can't think of any. Those refer to a particular condition, and when you see that, if I were to go back to the previous slide and they said, you know, we're looking at the distribution of class given that they had survived, then we would only be looking at, let me get this up here, we would only be looking at, if I can get this to work, there you are, this right here. And that's what you're seeing on the page that followed. All of this does not matter because nobody asked a question about it. So we don't even pay attention to it. We only ask, or we only look at the condition that we're being presented with. And we shrink our table down to that condition. Okay, so let's scoot forward. And let's see if I can get off of this pen. Okay. So the following is the conditional distribution of ticket class given having perished. All right. So we can figure these all out. So we've got for third class, 528 out of 1,490 is 35.4. 122 out of 1,490 is 8.2. And that would be the number or the percent of the first class passengers given that they had died. So we cross out those that lived, and this is the world we're in. Conditional distributions. So there's a lot of things we can talk about in contingency tables. All right, so conditional distributions tell us that there is a difference in class for those who survived and those who perished. Yeah, I mean, look at it here. This is for the crew. These are those that lived. These are those that died. If you're in the crew, that's not good news. For your third class passengers, these are the ones that lived. These are the ones that died. That's not good news either. It says it's better shown with pie charts of two distributions. I actually like to look at segmented bar graphs and do them in a comparative setting. So I think those are next. Because remember, I don't ask you to build any pie charts. So given what we just saw, we see that the distribution of class for the survivors is different from that of the non-survivors. And this is an important concept, and this does appear over and over and over in the course. So from what we just saw, where those two pie charts are different, it leads us to believe that class and survival are associated. So for example, if I tell you, okay, I'm just going to look at the passenger manifest, and I'm going to pick out a third class passenger, then given what you just saw, you can tell me that there's a good chance that person died because more of them, or a higher proportion of them, did die rather than lived. And if you can say something like that, then you've got a dependency because you're making a connection between two variables that you might not be able to make. When you can't make a connection, then the two variables are unrelated or independent. But if you can, then they are not independent, or there's a dependency. So the variables would be considered independent when the distribution of one variable in a contingency table is the same for all categories of the other variable. Now that's going to be a little bit weird, but let's go ahead and look at this a little closer. Okay, so here is segmented bar graph. In other words, I just took those two pie graphs and I converted them into these comparative segmented bar graphs, okay? And here's your crew. Remember, more of them perished than lived, or a bigger proportion. And for third class, same thing, a higher proportion perished than lived. But the good news is if you're in the first class or the second class, here's your ones that lived. They're about, what, 45% of the entire crew. Here, as far as the perished, of those that lived, about 45% of them were either first or second class. Here, in the perished, looks like there's only, I'd say 5% of the total who perished were first or second class. So it was probably a good thing for you to bribe your way onto a lifeboat because you had the money or the wherewithal to do it. So looking at this, it would tend to tell us that the higher the class of the passenger, the more likely the rate of survival. There's your dependency. If you could look at this and not be able to tell, then they would be independent. All right, so I put together a kind of a makeshift comparative group of segmented bar graphs where they would be perfectly independent. So here it comes. All right, now this did not happen, but let's pretend it did. Look at the difference between the alive and the perished for the crew. There's no difference proportionately. Same thing for third class, same thing for second class, same thing for first class. If I were to tell you that I'm going to pick somebody at random out of the passenger manifest and they ended up being first class, could you tell me there was a bigger chance of them living or dying? Or would you be able to say there's a good chance this person died? Well, not really, because they could have died or lived. There's no way to know. Same thing for second class, because they're in at the same proportion. All the way through, they're like that. So if I just point over and say there's a crew member and they're headed for an iceberg, you could not tell me, oh, there's a bigger chance that person would die or a smaller chance that that person would die. If you can't say that, it's independent. If you can say that, like back at this previous one, if I say, okay, there's a crew member, you could say, oh, there's a good chance that person died because a higher proportion of them did die. But here, they're exactly the same. These are independent. The ones prior were dependent. So is the relationship between survival and class demonstrated in these two segmented bar graphs? When your proportions are the same, variables are independent. That's very rare, by the way. So if I told you a person was selected at random was a member of the crew, you would have no clue whether he was a survivor or not. And you don't know for a fact in either setting if they lived or died, but if you can say it looks like they may have, then that's a dependency. Sorry, I didn't mean to beat that to death. All right, here is a variant of the graph we saw, not this one, but this one. See how these are kind of the same width? If you go to the Mosaic plot, look, the perished seem to be a lot wider than those who lived. And there's a reason for it. It's because there were just more of them who perished than who lived. Okay, so this not only shows you the proportion, because you can still read proportion, but the width actually tells you that there was a higher magnitude. Yeah, so that's what the whole theory behind a Mosaic plot is. So if there was 1/3 of them, of the people on the ship lived and 2/3 perished, you could work the relative magnitude into this graph and make some conclusions here. So yeah, interesting. So if you look at this, for example, it may be that this shows a bigger proportion were in the first class that lived, and here it's smaller from the first class for those who perished. It may be that more overall perished just because there's more area here. I don't know that for a fact, but that gives you some idea of the actual count of the people and not just the proportions. All right? Hope that makes sense. So what can go wrong? When you've got these conditional situations, you've got to pay attention to what the condition is. So don't confuse similar sounding percentages. Pay particular attention to the wording of the context. For example, what percentage of the seniors are males? All right, so you're only going to be looking at seniors, and you're going to find out of however many of those were male, and that'll give you some sort of percentage. So you're only looking at the senior group. We want the percentage of males. What if they change it around and say what percentage of males are seniors, right? Now you're looking at only the males and ignoring the females, and out of all the males, what percentage are seniors? So you got to just think about it. All right, so for AP tips, now look, they don't often make you draw graphs. On an AP exam, this is a timed exam, and drawing a graph takes a lot of time. So they often will provide you the graph. In fact, practically all the time. Rarely they might have you jot down something quickly, but for the most part, they'll give you the graph and ask you to find meaning in it. But if you do, give your labels, give your titles, scales correct and appropriate. Just make it as formal as I taught you to do. And you can read the little cartoons for your own amusement. Here is your homework. It's homework number 3. You can go and find that in reprints, and those are the numbers, and there should be a key posted for you. So I want to just conclude right now, because I'm not supposed to run this too long. You know that you can watch this, speed it up, slow it down. You can print out the PowerPoint beforehand and jot down things that you want to jot down. However you want to work this is up to you. So on that note, I'm going to wish you a fabulous weekend. Hopefully you can recoup from this crazy first 3 days, and we'll just come back at this on Monday. Bye.